Hi, my name is Khurram Wahid. I am the team leader for group number 1, part of cloud computing course SIT 706. This is our assessment number 2, task number 2, which is basically creating a 10-minute video for our group project. My group consists of myself. I've got other team members, Shekhar Diani, Shahida Siddiq, and Hung An Tran. What I'm going to go is I'm going to go over a quick topology within our deployment for the project. What we did was we came up with the concept of migrating a customer from an on-premises environment into an AWS cloud infrastructure. And we wanted to demonstrate how easy it is to secure network visibility from within the east-west corridor as well as the north-south corridor of AWS cloud computing environment. So what we're going to do is, as you can see on the screen, we will create an AWS VPC in our region, which is in Sydney, in Australia. Then we'll spin up a VPC. The name of the VPC would be SIT 706 group number 1. We'll allocate it public and private IP addresses or subnets. Then we'll create some internet gateways and NAT gateways into it. And then we'll go ahead and associate some route tables, both public and private, with it. Then once that has been done, what we'll do is we'll spin up 2 different instances, which are called EC2 instances, which are basically IaaS workloads in an AWS environment. One of these instances is going to be a source workload. So think about an on-premises customer who's got, for example, some sort of a server. In our example, we're going to do this quick. So it would be a Bastion instance, which would be hosting an SSH server on top of it. We'll also use that Bastion instance as a client to establish HTTP queries outbound, as well as just showcase some DNS lookups from this Bastion host. Now, what we want to do is we want to use a VPC traffic mirroring feature, which is natively available within AWS. We'll invoke that. We'll set up the environment so that the traffic of this guy, east-west within the same VPC, as well as north-south from outbound into this or incoming into this VPC towards this instance, would be mirrored leveraging this function into an ExtraHop AMI. ExtraHop is a cybersecurity company, and they have a sensor that you can securely and passively deploy in the environment. It ingests network traffic and reconstructs everything from the traffic. So that's a basic summary of our deployment. What I'm going to do is I'm going to go ahead and showcase of how did we go ahead and configure that in AWS environment. So as you can see my screen, I'm into the console of AWS. Within the console, I'm under the services. I go into VPC. That's why I created a VPC. So as you can see, there's a bunch of different services provided within AWS. We went into the VPC and we created a VPC from here, okay? Now, all of those details of how exactly step-by-step we created that VPC, that's available in our PDF that we submitted as part of the group. This is a VPC which is already created. As you can see, the name of the VPC is SIT 706-group1-VPC. The key information that I had in this VPC is the CIDR block that you have to allocate to it. That's how you go ahead and create this. So once the VPC has been created, the next step that you have to do is you have to create some subnets into them. So as you can see, we created 2 different subnets. One is called the public network as well as a private subnet. So this belongs to that, you know, //16 CIDR. But as you can imagine, we further segmented this. So the public network that I've got, that subnet is 10.0.1.0/24. And there are 248 available IP addresses. And for the private subnet, we've got that. So if I click on the properties of this subnet, you can see that the status of this subnet is available. You have to specify the availability zone that this subnet is going to be available in. So this is Asia Pacific-Southeast-2A. And the CIDR block is from within that. Cool. Now, the other private subnet that I had, you know, create on the private subnet, again, that belongs to AP Southeast-2A. And the CIDR block is completely different. After the creation of the subnets, what we have to do is we have to create an internet gateway. That internet gateway is named this, so SIT 706-group1-IGW. The key thing about the internet gateway, it acts like a virtual router. It has to be attached to the VPC, which we've attached right here. The whole purpose of this is that any of the workloads within the VPC need to use this internet gateway for outbound comms, and any of the inbound comms come via this internet gateway. So this has to be created. And subsequently, I'll show you how it is attached. Now, besides that, what you also have to do is you have to create a NAT gateway. NAT is network address translation. So any of the traffic which goes from your private IP address space into the public IP address space needs to be translated. So that's what we did. So we created something called sit706-group1-NAT gateway. As part of that NAT gateway, what we did was we stitched it across to our VPC, and we gave it an elastic network IP address. And here's the elastic. Elastic IP is like a dynamic IP, which is allocated to this subnet, to this NAT gateway by Amazon AWS. Okay. So once we create the NAT gateways and the internet gateways, then what you got to do is you have to allocate the route tables. Route tables belong to the router. So the internet gateways as well as the NAT gateways. But what you got to do is to that public route that you've created, you need to specify the routes going out from them. So there's a local route in there that's by default, but then there's an all route out. So for example, anything. So if the destination is anything from within that public route table, then you go ahead and point it towards internet gateway. That's like a default route. So any of the traffic which needs to go to the internet, then that needs to be pointed towards a target, which is the internet gateway. And then we will also do is we associate this public route table with the subnet ID, which is the public network. So that, that route table is associated with the virtual router, but a specific route table. The same thing is what we did with the private route. So you can see the private route has a default gateway, which is pointing towards the NAT gateway. Obviously, that's a private subnet. And we associated that subnet with a private route table. So that completes the configuration that we had for the VPC as part of step number one. Now, once the VPC was created, we had a couple of different tasks. One task was to go ahead and instantiate an ExtraHop Reveal X EDA1100V, which is like a sensor. So what we did was we created a CloudFormation template. CloudFormation template is like a series of steps within AWS where you specify this is what I have to do. So I have to create, for example, a VM as an example. And within that VM, it needs to have so many interfaces, management interfaces and capture interfaces and so many IP addresses. And this should be the NTP configuration and everything. So you roll them up, you specify them in a cloud formation template, and that cloud formation template then fetches that image and does everything which you've spoken out. So as you can see, I've got two different stacks that I created. Both are completed. So this was the first one that we created, so SIT706 group 1-EDA. So EDA means ExtraHop Discovery Appliance. This is basically there to spin up the ExtraHop EDA instance. And so if I click on the resources, you can see there's a bunch of things which are in there, right? So here's an S3 bucket, which points across to the target to fetch the image from. Then you've allocated an elastic IP to this. So using this, I can access the ExtraHop console once it is created completely. And then you give it an attachment of that. Then you specify the instance types, because ExtraHop could have different types of instances, 1 gig, a 10 gig, a 25 gig. So we're basically specifying which one do you have to do. We create some security groups. We specify some management interfaces. We specify the capture interfaces that need to be created as part of them. Then we specify that you have to have an ELB instantiated as part of this as well, right? And finally, you need to have some targets. Targets are used to tag the traffic for it to be using VPC traffic mirroring feature. So based upon this, once this was successful, what it did was it gave us, for example, the IP address that you can use to go ahead and connect into this EC2 instance, and then do whatever you want to do from there. So that was one thing that we created. Now, the second thing that we also had to do was to instantiate an EC2 instance, a Bastion host within that east-west corridor environment. So as you can see, if you click on that, we've got two different EC2 instances, right? So EC2 instance one is EDA. You can see that this is running. Here's the instance ID. This is type c5.xlarge. Here's the public IP address of that. Here's, for example, the private IP address of this. And as you can imagine, the private IP address of this instance belongs to the 10.0.1 subnet, which, as you can imagine, was the private subnet that we associated with it, right? And then the other thing that we also created was a Bastion instance. A Bastion is there to host something so that we could, play with that and see exactly what traffic is egressed out of it or ingressing into it. How we did was, although we've captured the steps in the presentation, in the PDF, you can see if I wanted to go ahead and create an instance, I would go ahead and instantiate it. So as part of that creation, what you can then do is you can see what did I do? So the instance type is running, but what is the types that I specified with it? It's an AMI. AMI is an Amazon machine image. That's a 64-bit image. As part of that build, go ahead and have, for example, EBS volumes created with it. And eventually an IP address is allocated across to it, right? So if I go into instances, what I can also do is I can create an instance. And I can, if I wanted to go ahead and I could go ahead and stop the instances as well. Yeah. So if I click on launch instance, it's going to ask me to go ahead and create something from scratch. So this is what I selected. This is free tier eligible within them. So that's an Amazon Linux 2 AMI. AMI stands for Amazon Machine Image. It's a specific build that you can quickly go ahead and provision. It's a 64-bit. If I, for example, go ahead and select this, it's going to ask me for additional information, right? What instance type do you want to go ahead and create? We basically selected a T3 micro with 1 gigabytes worth of RAM, 2 vCPUs, and EBS storage allocated across them. So that's how we provisioned this instance. So now, as this is running, both the instances running, what we now want to do is we want to allocate some specific tags to it so that the traffic of this instance is piped across to ExtraHop. Yeah. So as part of them, what we did was we went to the CloudFormation template again, and we provisioned as part of them a new stack, which is called VPC Traffic Mirror. At the back end of it, what it does is it allocates specific tags via Lambda services. Yeah. So that's what it did. So once we created all of them, eventually the whole idea was that towards the output of it, it should have some functionality which is native to Amazon, which is called traffic mirroring. So traffic mirroring session is set up. When the EC2 instance is tagged across to it, you can see, for example, there's a session ID, which is already created. There's a source ENI, which is that EC2 instance, which is the Bastion host. And here's the target of that, of where to send the traffic across. You can see the mirror targets that we've got, that's the EDA target. So we're going to send it across to the capture interface of this. And that capture interface is loaded behind a network load balancer. Okay. So if I click on, for example, the target ID, one of the key things that I have to confirm is how am I allocating this service a tag. So we allocated as part of our provisioning stack a SIT706 mirror tag across to it. So anybody who's got, as an EC2 instance, has got a mirror tag allocated to it, its traffic is going to be piped across to the network load balancer and eventually onto the capture interface. And the filter for this guy, we also have to confirm that the filter has that tag as well. So SIT706 mirror. So once we go into the mirror sessions, once this is all cleanly set up, then you can see that a target is automatically created with that mirror and the traffic is automatically piped across to it. So how do we go about this? What we're going to do is we're going to say, okay, now I want to go into my EC2 instance, and that EC2 instance that I've got, a couple of those are running. I'm sourcing the traffic from here, but I want to see the collector because the collector is capturing everything. So I click on the instance ID. Look at this. I've got an IP address of 54.153.206.203. That's the public elastic IP, which is given to me. I click on the open address and it opens up my ExtraHop console. So this is the ExtraHop console, which is receiving the traffic. So what I'll say is, note first of all, the IP address is the same, 54.153.206.203. This is the UI of ExtraHop instance. So I'll say in the past 30 minutes, show me ExtraHop, what have you automatically discovered? I go into the assets. I can see there's a bunch of different traffic types. There's one client and ones are active, and we're automatically parsing the protocols. But prior to the protocol parsing, I want to see what are the active devices. You can see here's the gateway. So from within the AWS environment, but here's the actual EC2 instance, which is 10.0.1.126. You can see that we're sniffing the IP address from within that VPC. So, and here's the MAC address of that. So if I click on that guy, I can now see exactly what is happening with this guy. So in the past 30 minutes, the protocols inbound that it has received, what's the MAC address, what's the IP, when did I see this? First of all, in the past 30 minutes, I can see that he's active right now. Inbound protocols, I've received NTP. There's NTP protocols. He's talking across to a bunch of public IP addresses. Then I go back into the past 1 hour. I see, was there another baseline of the traffic? I can see right there that the baseline changed. From a public IP addresses perspective, he's also talking to an IP which is in Melbourne, Australia, which is my own public IP. So if I say, what's my IP? you can see that it points to my public IP, which is 119.17.146.82, which is exactly what my IP address right here is. So this instance within AWS is talking across to him. Also, some of the other attributes of this, you can see the times used charts in there. You can see, for example, that he's ingesting HTTP traffic and he's sending requests out for a bunch of DNS protocols as well, right? So as a client, he's behaving as a DNS client. As a client, he's also doing some HTTP as well as SSL traffic. But as a server, he's hosting an SSH server. So now what we're going to do is we're going to quickly simulate something. So what I'm going to do is I'm going to open up the console. So I've got a secure CRT session. I'm going to exit out of them. And I'm going to reconnect. So what I'll say is go and connect into this instance. So this is, again, the same IP address that I'm hooked into. So I go ahead and I say a bunch of different commands, right? So who am I? So I've got a Unix shell available to uname -a. Then I'm going to do some NS lookups. So I'm going to say, give me the IP address of a domain called deacon.edu.au. So these are the DNS queries as a client from this Bastion host that I'm doing right now. Okay, then I'm going to say, okay, give me the IP address of cisco.com. Just simulating some of the traffic from here, right? Or juniper.net. And then I'm going to say, go ahead and ping somebody. So ping, for example, google.com. So it's going to go ahead and shoot out some ping commands in there too. Then some of the other commands that I'm going to run. I'm going to simulate some HTTP commands outbound to a HTTP host. Okay, so what I'll do is I'll say curl something. So curl is a command that I go ahead and use to fetch an object. So it simulates then, for example, that I'm doing, this is like a loop. So I'm going to go ahead and curl for 100 times, request a HTTP web page of info.cern. And basically what I'm going to do is from this host, when I simulate these commands, I'm going to see what's going on. So right there, it executes a bunch of different commands 100 times, right? So we're going to see the impact of this on the server side of it. And it keeps on running, 100 times. It's going to go ahead and request a web page instead of me, statically going to a browser. This is one of the simulation tests that people do. And it obviously works like a request. Okay. So whatever number of commands that I did, I'm also going to go ahead and do curl.something into a specific web page. Yeah. Hosted onto this website. So kind of like this. So I'll say 10 times, go ahead and do this. Cool. So this is network traffic being sent out from that EC2 instance, which resides in an AWS VPC, and the collector should then go ahead and collect all of those transactions and see what's going on with this. So the whole project was network visibility in the cloud computing environments, and that's what we're demonstrating. So this is all running within AWS as an environment, right? So then what I do is I say, okay, show me in the past 30 minutes, what sort of traffic type did I have? So I go ahead and refresh this. As you can see, it's a 30-second interval metric within ExtraHop. So I could see right here when I executed some commands, there was an SSH inbound connection coming in, traffic coming in. And as an outbound traffic type, there was some DNS commands and there was some HTTP commands, some SSH sessions and everything, right? So then I can go into specific layers. I can see, okay, show me the specific attributes of SSH in the past 30 minutes. So what SSH session was established? What was the cipher type? Who was the client who established that session? As you can imagine, this is my public IP of my home gateway where I'm establishing an IP and SSH session into that server. Then some of the other things that I want to see, I want to see, what DNS requests did I do? So as you can see, this is now parsing the client activity of DNS. I click on host queries, and some of those queries I did info.cern and I did www.cisco.com, and you can see the time series charts of when did I send those one of each command, juniper.net and extrahop.com and deacon.edu.au. I also did some HTTP curls as a client. So if I click on the HTTP layer, automatically I can see that there were 30 plus responses sent out from that server. Well, the URIs, I click on that URI layer, I can see info.cern was fetched 43 times. And the project.html URI hosted onto that server that was fetched or curled 10 times, was the status codes, and we're, enumerating or surfacing the layer 7 attributes of all of those guys. So where is this hosted? What is the content type and everything? all of that information is automatically visible to us. So basically what this proves is that we can automatically discover anything and everything within a cloud computing environment. We demonstrated by using an AWS environment. We spun up a VPC. We allocated some subnets and everything in our gateways and NAT gateways. We spun up EC2 instances. We piped the traffic, and we proved that anything without any agents, without any logs from the network can be surfaced leveraging cloud native features. Thank you very much. This was group number 1. The project title that we had was Network Visibility within the Cloud Environments. My name is Khurram Waheed. Thank you very much.